Week 5 quiz. Use the cell method to compute the volume of the solid obtained by rotating the region bounded by x equals y squared, x equals 1, and y equals 0. So those three functions give you kind of like a triangular region. Okay, so where is y equals 0? Is the x-axis. Where is x equals 0? Is this vertical line. And x equals y squared should give you like a sideways parabola, but because it's bounded below by y equals 0, you only want this top part. Okay, so this is a region that we need to rotate, and the line, the axis of rotation is y equals 3. Okay, so y equals 3, x equals 1 is a vertical line, y equals 0 horizontal line, and x equals y squared. So how do we use the shell method? And I can show you the this method so that you know this is the correct answer. So to find the shell, right, we need to integrate 2 pi times r times the height. So what is the r, or what is the height? Okay, so how do we find out? So you have to draw a picture. I'm going to use a blue line. So because you are revolving this way, right? So this should be the height of the shell, and this should be the radius. So I'm going to use a different color. This is the radius of the shell, and h is the height. So 2 pi r times h. Okay, so how do we figure out the r? So we need a point of reference. And look, r is parallel to the y-axis. So at this point, y is at this value. And at this point, the value for y is 3. So the r is just 3 minus y. Experience. Okay, so h, how do you find h? So you have to look at the endpoint of h, right? What is this endpoint? X equals 1. What is this endpoint? Okay, what line is, or what curve is on? It lands on x equals y squared. So minus y squared. Okay, so how do you figure that one out? Well, x equals 1. How do you figure that one out? X equals y squared. So this is our integral, okay, with respect to y. And what is y ranging from? It's from this point, 0, to this tip up here, which is 1. So 0 to 1. So you should be able to do this. It's a polynomial about y, okay? So factor out the 2 pi and so on. You should get the answer as 7 pi over 2, and it's approximately 10.996. So if we need to use a disk method, how do we go with it? You have to draw a different picture. I mean, I can use the same picture, so disk. And I'm going to draw the picture again, but using different lines. Okay, so your line is still y equals 3. Now for the disk method, okay, you need to find your outer radius, capital R, and your inner radius, little r. Okay, for the disk method is pi r squared, right? But the outer, capital R, square. So subtract the inner ring, right? Little r square. This or washer method, however you want to call it. But the idea is the same. So because you're rotating like this, and each line here will become, it's going to give you a disc, a circle. That's why it's pi r squared. Now how big is capital R? It's from line 3 to 0. Okay, so R is 3 minus 0. So y equals 3 to y equals 0. So you subtract them. 3 minus 0. It's just 3 squared. Okay, you subtract little r. Little r is also from y equals 3 to what? Y equals square root of x. Okay, so 3 minus square root of x square. Okay, because that's little r, and then you do the square. You take the derivative with respect to x, because right now we are talking about the this or washer method, and your x range from 0 to 1. Okay, 0 here, 1 there. Different method, you might need to use different axes, but it's still going to give you the same answer, 7 pi over 2, and it's still approximately 10.996. So I hope you understand how two different methods are set up differently, and I hope you try it again so that you can get the correct answer.